Hi, and welcome to this video on biodegradable polymers and ways in which we can reduce the negative effects of commonly used polymers on our environment. What is a polymer? A polymer is a long chain built up of a repeating unit called a monomer, as poly means many and mono means one. An example of a polymer used in everyday life is polyethylene, which is made of repeating units of ethene molecules. There are a variety of methods for forming polymers, and polyethylene is formed through free radical polymerization. In the initiation process, an initiator, such as an organic peroxide, splits into two radicals through homolytic bond fission, which breaks the weak oxygen-oxygen bond, leaving each radical having one unpaired electron. The pi electrons in the ethene molecule splits homolytically, with one pairing with the peroxide radical to form a bond, and the other remaining unpaired, forming a radical. This radical can go on to react with another molecule of ethene, causing the chain length to increase quickly. Lastly is the termination step, where two radicals come together to form a long polymer molecule. Polymers are used in everyday life. For example, polyethylene is a versatile polymer, as it comes in both high density and low density forms. Low density polyethylene can be used to make plastic bags, as it is flexible, and high density polyethylene can be used to make detergent bottles, as it is a stiff plastic. Other uses of polyethylene include electrical insulating and water pipes. However, there are a range of polymers that have many other uses too, from protective clothing to aircraft parts. So, what's our issue with polymers? It's obvious that polymers are used in many parts of day-to-day life, and if we bounce back to our last slide, you can see polyethylene is used to make plastic bags. It has been estimated that in the course of a year, we use 5 billion to 1 trillion plastic bags worldwide. That's over 1 million bags per minute. And plastic bags are notoriously bad for our environment. The first issue is that, like most polymers, polyethylene is made from crude oil. Crude oil is a non-renewable resource, which makes this method unsustainable. Furthermore, if incinerated, it will produce CO2, and 5 plastic bags contribute to up to a kilogram of carbon dioxide, which contributes to global warming. This effect can be reduced by recycling plastic products instead of incinerating. This sounds ideal, but it has been suggested that as little as 9% of plastic bags are actually recycled. The majority of plastic bags produced end up in landfills, where they can take up to 1,000 years to decompose. Not only does this take up a lot of space, it is unsustainable and decreases the amount of land that can be used for other purposes, such as farming. Plastic bags also end up contaminating our environment, both on land and in the ocean. This can lead to lasting and devastating effects for wildlife, as plastic bags may be mistaken for food. For example, it has been said that 50% of sea turtles have plastic in their stomach. As they do not decompose within the stomachs of animals, this can lead to starvation. Is this all worth it for a plastic bag that is used for an average of 12 minutes? So, what are the alternatives? A simple solution could be the paper bag. Paper bags are made of cellulose, a natural polymer of beta-glucose that occurs in plants, with hydrogen bonds between the polymer chains making the material strong. Therefore, paper is made from a renewable source, as it's made from trees. It's biodegradable, as they break down naturally in the environment, and can be considered carbon neutral, as the carbon taken in through the lifetime of trees is released from paper bags when they're broken down. So why don't we all convert to paper bags? Well, even though it is a renewable source, cutting down trees enough to fuel our bagging needs could lead to deforestation. Furthermore, compared to plastic, making a paper bag leads to 70% more air pollution, consumes 4 times as much energy. And the Environmental Protection Agency has said that in landfills, due to the lack of oxygen, paper bags do not biodegrade that much faster than plastic bags. This suggests that paper bags may not be as feasible as we thought. So, what about biodegradable polymers? Biodegradable polymers are polymers that are also made from crude oil. But they are engineered with additives to make them break down quicker. An example would be oxo-degradable polymers that contain transition metals such as manganese, cobalt and iron. These additives promote oxidation of the polymers, which leads to the polymer breaking down into smaller chains, so microorganisms can digest them faster and more easily. However, it has been suggested that fragments themselves do not easily biodegrade and will remain in the environment. Furthermore, these can be found to accumulate toxic chemicals and transport them to marine environments. Furthermore, in landfills there is little oxygen present, so if biodegradation occurred, it would be anaerobic, which results in the production of methane, a harmful greenhouse gas. An alternative option could be bioplastics, which are another advancement in environmentally degradable plastics. Bioplastics are not made from petrochemicals. Instead, they are made from natural materials. A common example is PLA, polylactic acid, which is made from cornstarch. PLA is a polymer of lactic acid, which when polymerized contains many ester bonds. This means it's able to be broken down by hydrolysis reactions, as the ester bonds make the carbon bonded to the oxygen delta positive due to the electronegativity of the oxygens. Therefore, it is susceptible to attack from a nucleophile, such as a hydroxide ion, and this can cause the polymer chain to break. PLA can also be broken down by enzymes secreted by microorganisms. For example, it can be hydrolyzed by the lipase from R-delamar and the proteinase K from Trituraceum album. This is an improvement on biodegradable polymers, as they could be considered to be carbon neutral, as carbon taken in during the lifespan of corn is then released again when the polymer is broken down. However, it has been suggested that PLA may not break down quickly in landfills due to the lack of oxygen, and in reality it will need to break down in an industrial-controlled composting environment heated to 140 degrees Fahrenheit, which is roughly 60 degrees Celsius. Furthermore, bioplastics can be mistaken for regular plastics and may accidentally be put into recycling. When this happens, the entire collection cannot be recycled, which may cause less regular plastics to be recycled. So, what's the solution to our plastic pollution? First of all, we could make a conscious effort to reuse our plastic and make sure that we do recycle them properly. For bags made of natural, renewable sources, such as paper or bioplastics, ensure that growing and harvesting the natural product is controlled to prevent deforestation or wasting land that could be used to grow crops for food. Lastly, we should all take responsibility for our plastic consumption and try to decrease the amount of plastic we use daily. This can be done by investing in reusable, non-plastic products, such as canvas bags, stainless steel water bottles, and even shampoo or shower bars that do not come in plastic packaging.